Hey there, science fans. Welcome back to another exciting episode where we unravel the mysteries of the universe. Today, we're going to explore a topic that's all around us, yet often goes unnoticed. It's something that affects our daily lives in more ways than we can imagine. Today, we're diving into the fascinating world of heat transfer. Heat transfer is a fundamental concept in science and engineering, and it plays a crucial role in everything from cooking your food to powering your car. But what exactly is heat transfer? And how does it work? Ever wonder how your coffee stays warm in a thermos or how a radiator heats your room? These everyday occurrences are perfect examples of heat transfer in action. When you pour hot coffee into a thermos, the heat from the coffee is transferred to the walls of the thermos, keeping your drink warm for hours. Similarly, a radiator transfers heat to the air in your room, making it cozy and comfortable. It's all about heat transfer. Heat transfer can occur in three different ways: conduction, convection, and radiation. Each of these methods involves the movement of heat from one place to another, but they do so in unique ways. Heat is energy on the move. In conduction, heat is transferred through direct contact between molecules. Think of a metal spoon getting hot when placed in a pot of boiling water. In convection, heat is transferred through the movement of fluids, like the warm air circulating in your room from a radiator, and in radiation, heat is transferred through electromagnetic waves, like the warmth you feel from the sun on a sunny day. It always flows from hotter objects to colder ones. This is a fundamental principle of thermodynamics. Heat naturally moves from areas of high temperature to areas of low temperature, seeking equilibrium. This is why your hot coffee will eventually cool down if left out in the open, as the heat is transferred to the surrounding cooler air. Think about it like sliding down a hill. Just as objects tend to move from higher to lower elevations due to gravity, heat moves from higher to lower temperatures due to thermal energy. This natural tendency is what drives the process of heat transfer. Heat naturally wants to go from a high-energy state to a low-energy state. This is why you can see steam rising from a hot kettle as the heat energy is transferred to the cooler surrounding air. The same principle applies to many other everyday phenomena, from the warmth of a campfire to the cooling effect of a fan. This temperature difference is the driving force behind heat transfer. The greater the difference in temperature between two objects, the more rapidly heat will flow from the hotter object to the cooler one. This is why a hot cup of coffee cools down faster in a cold room than in a warm one. The bigger the temperature difference, the faster the heat flows. Pretty cool, right? This principle is used in many practical applications, from designing efficient heating and cooling systems to developing advanced materials that can withstand extreme temperatures. Understanding heat transfer is important in tons of things. It's not just about keeping your coffee warm or your room cozy. Heat transfer is a critical factor in many industries, including manufacturing, aerospace, and even healthcare. Engineers and scientists use their knowledge of heat transfer to solve complex problems and create innovative solutions. It helps us design better buildings, ensuring they are energy efficient and comfortable to live in. By understanding how heat moves through materials, architects and engineers can create structures that maintain optimal temperatures with minimal energy use. Keep our food from spoiling by designing refrigerators and insulated containers that slow down the transfer of heat, keeping our food fresh for longer periods, and even explore outer space. In the harsh environment of space, managing heat is crucial for the survival of astronauts and the proper functioning of spacecraft. Heat shields, thermal control systems, and other technologies are all based on the principles of heat transfer. So the next time you enjoy a hot cup of coffee or feel the warmth of a radiator, remember the incredible science of heat transfer at work. It's a fascinating world, and it's all around us. Heat is a real traveler, moving from one place to another in fascinating ways. It's an essential part of our daily lives, even if we don't always notice it. Whether it's the warmth of the sun on our skin, the heat from a stove, or the steam rising from a hot cup of coffee, heat is constantly on the move, and it's got three main ways of getting around: conduction, convection, and radiation. Each method is unique and plays a crucial role in how heat is transferred in different environments and situations. Conduction is heat transfer through direct contact. This is the process where heat moves through a material without the material itself moving. It's like a chain reaction where one molecule bumps into the next, passing the energy along. Imagine touching a hot stove. Ouch, the heat travels from the stovetop right into your hand because the molecules are bumping together. This is why metal objects, which are good conductors, can get very hot very quickly. The heat travels from the stovetop right into your hand because the molecules are bumping together. This process is very efficient in solids, especially metals, where the molecules are closely packed together. The energy transfer is quick and can be felt almost instantly. Convection is heat transfer through the movement of fluids, like liquids and gases. This method relies on the physical movement of the fluid itself to transfer heat from one place to another. Think about a pot of boiling water. As the water at the bottom of the pot heats up, it becomes less dense and rises to the top. Meanwhile, the cooler water at the top sinks to the bottom to be heated. This creates a continuous cycle known as a convection current. The hot water rises, cools down, and sinks again, creating a circular motion that distributes heat. This is why stirring a pot of soup helps to evenly distribute the heat, ensuring that every part of the soup gets warmed up. Radiation is heat transfer through electromagnetic waves. Unlike conduction and convection, radiation doesn't require a medium to travel through. This means heat can be transferred through the vacuum of space. The sun is a great example. It sends heat our way as infrared radiation, which we feel as warmth on our skin. This is how we receive heat from the sun, even though it is millions of miles away from Earth. It sends heat our way as infrared radiation, which we feel as warmth on our skin. This process is crucial for life on Earth, providing the energy needed for plants to grow and for maintaining the planet's climate. So, the next time you feel the warmth of the sun, remember the incredible journey that heat has taken to reach you. Let's see these heat transfer methods in action. When you cook an egg in a frying pan, conduction transfers heat from the burner to the pan and then to the egg. Convection is at work when you bake cookies in an oven. The hot air circulates, baking those delicious treats evenly. Radiation is how you feel the warmth of a campfire. The flames emit infrared radiation that travels through the air and warms you up. Section 4. Heat conductors and insulators. In this section, we will explore the fascinating world of materials and how they interact with heat. Understanding the difference between heat conductors and insulators is crucial in many aspects of our daily lives. Some materials are better at conducting heat than others. This property is essential in various applications, from cooking to building construction. Conductors and insulators play distinct roles in how we manage and utilize heat. Metals, for example, are excellent heat conductors. They allow heat to pass through them quickly and efficiently. This is why metals are commonly used in cookware and other applications where rapid heat transfer is needed. That's why pots and pans are often made of metal. They transfer heat quickly and efficiently. When you place a metal pan on a stove, it heats up rapidly, allowing you to cook your food evenly and quickly. This efficiency is due to the high thermal conductivity of metals. On the flip side, we have insulators. Insulators are materials that do not conduct heat well. They are used to prevent the transfer of heat from one place to another. Materials like wood, plastic, and rubber are poor heat conductors. These materials are used in situations where we want to avoid the transfer of heat. For example, a wooden spoon is used in cooking to stir hot food without getting too hot to handle. They resist the flow of heat and are great for keeping things warm or cold. Insulators are essential in everyday items like cooler bags and lunchboxes, which help maintain the temperature of their contents. Think about your trusty thermos. It keeps your drink hot or cold because of its insulating layers. The thermos uses a vacuum layer between two walls to minimize heat transfer, ensuring your beverage stays at the desired temperature for hours. This principle of insulation is applied in many other areas, from home insulation to protective clothing. Section 5. Heat exchangers, swapping heat like a pro. Heat exchangers are like the middlemen of heat transfer. They allow heat to transfer between two fluids without the fluids actually mixing. Pretty neat, huh? There are different types of heat exchangers like shell and tube, plate and finned tube exchangers. They all work by using conduction and convection to transfer heat efficiently. Heat exchangers are used in tons of applications, from your home refrigerator to giant power plants. They're essential for heating, cooling, and many industrial processes. Section 6. Heat transfer at your service. Heat transfer is everywhere in our daily lives. It's how we cook our food, heat our homes, and even cool our computers. We use heat exchangers in refrigerators to keep our food cold, in air conditioners to cool our homes, and in cars to regulate engine temperature. Understanding heat transfer helps us design more energy-efficient buildings, develop new technologies, and even solve environmental challenges. Section 7. Keep the heat flowing. So there you have it, the basics of heat transfer. We've learned about conduction, convection, radiation, heat conductors and insulators, and the wonders of heat exchangers. Heat transfer is a fundamental process that impacts our lives in countless ways. Keep exploring, stay curious, and never stop learning about the amazing world of science.